Hi everyone. Thanks for joining the webinar around cold chain monitoring, organized today by Laird Connectivity and the Things Industries. My name is Alexander Overtoom from the Things Industries, and I'll be your host for probably the coming 30 minutes. And in the bottom right of the screen, you'll see the miniature videos with Jonathan and Johan, the presenters, who are sitting tight to introduce themselves shortly. But before we start, a little bit of background. So we decided to host a webinar around the topic because of some overwhelming number of requests lately from companies who are looking to add monitoring to their cold chain, which makes us believe there's actually a strong need to better understand the enabling technology that is underneath it, and this presents an opportunity to those who are able to implement this technology, and that's what we are here for today to help you with that. So cold chain is about refrigerating of raw materials, finished products throughout the various stages of the supply chain. From production to transit, storage, before consumption. And it may not only apply to perishable foodstuffs, but it could also be pharmaceuticals or chemical products. But for this webinar, we've chosen the specialty of cold storage in professional food environments, such as restaurants and hotels, because we see a strong business case around food safety compliance, but also around the elimination of waste, both in terms of materials, but also waste in human resources. The technology that we'll present to you today is horizontal and will provide the building blocks, and it may essentially be applied anywhere where there's remote temperature or humidity measurements needed. So it will be quite generic, and that's what it's going to be about, the hardware and the backend systems, and in particular for LoRaWAN based monitoring solutions. And it's subsequently up to you, the systems integrator or the application providers, to actually develop the value added services on top of those building blocks, such as the data analytics, data visualization, etc. Because you'll have a better understanding of the contextual requirements, and you'll also have the channels towards the end users. So just going into the agenda for the coming 30 minutes, we'll start with an introduction from our two speakers. Then we'll briefly touch upon what is LoRa and LoRaWAN again, and then we'll take a deeper look at the challenges and the benefits of cold chain monitoring, and also discuss in detail the hardware products and the backend systems required to build robust and scalable solutions. And we'll finish off with the Q&A. So on your right, you see a navigation pane where you can also start a chat with us, with me, the host, but also with the two presenters, and we'll get to your questions towards the end of the webinar. So without any further ado, let me introduce the presenters, Jonathan and Johan. Jonathan, you go ahead.
Hello, so my name is Jonathan Kay. I'm a senior director in the product management team here at Laird Connectivity. I've been doing wireless connectivity and embedded designs for about 20 years now, really looking after our product portfolios of Bluetooth, Wi-Fi, LoRaWAN and some sub-gigahertz technologies, both from a modules and then also now a packaged product and gateways perspective. Johan?
Yeah, hello everyone. My name is Johan Stocking. I'm CTO and co-founder of the Things Industries, also tech lead of the Things Network. That's what we started with around 4 years ago. Also co-founded that. Started as a community initiative based in Amsterdam, and that spread really fast across the world. It's a really big developer ecosystem around LoRaWAN, and the Things Industries is really a commercial entity where we deploy solutions for our customers And I'm myself mostly involved in technology, architecture, technical strategy, and some business development. So yeah, let's take a look at LoRa and LoRaWAN. I think a lot of you that are watching already are familiar with LoRa and LoRaWAN, but those of you who are not, I'm gonna scratch the surface a little bit about what it really is, and also a little bit about the difference, because it's also quite confusing sometimes. So LoRa is a wireless modulation technology, so it's really meant for transmitting data through the air using very little power over long range. It's long range in dense urban environments is still a couple of 100 meters. When you have a line of sight in outdoor areas, for example, you typically have coverage even tens of kilometers of range are possible, and anything in between. So it really depends on the terrain. It's sub-gigahertz ISM bands, and that means that you can deploy a LoRaWAN network yourself, so you don't depend on any license for a spectrum. There are different, the ISM bands are not harmonized globally, so there are different regions defined also in LoRaWAN, where you need to be aware of, but this is a problem that is actually solved by gateway and device vendors. And the reason why it's you get such a long range is because of the link budget. And the link budget is really high, so you can, what is the theoretical range of LoRa is, I think it's around 850 kilometers theoretically, and there have been some field tests with weather balloons going beyond 5 milliwatts of power. So that's really what you get theoretically with LoRa. So it's a really great modulation for a low power transmit of data. We actually see a lot of use in LoRa also, not necessarily because of the range, but really also because of power, little use of power. So battery driven sensors that are installed somewhere in places that are hard to reach, or it's expensive to replace batteries. I think in cold chain specifically, batteries it's oftentimes can be challenging in battery driven use cases. LoRa can be used for the range, for the low power, or a combination of the two. So LoRaWAN is it's transmitted typically over LoRa modulation. It's an open protocol. It's two-way communication. It contains the session management, security, network layer, and application layer encryption. And it's governed by the LoRa Alliance. So LoRa Alliance has a technical committee where the specification is maintained and expanded. It's also, there is a specification on the regional parameters. So those are basically the rules for basically the base contract between devices and a network in different regions, so they can join any LoRaWAN network. There's also a standard on interfacing between different networks, and there's a LoRa Alliance certification. So many devices out there are LoRa Alliance certified, and that means that you can be sure that they work on LoRaWAN networks. So that's a short intro about LoRa and LoRaWAN. If you look at the topology, this is what a typical LoRaWAN network looks like. So you have on the left the end devices, on the right your application. Devices are covered by gateways, and gateways they listen on channels, typically 8 channels, can be 16 channels, and they forward all the traffic that they receive to the network server. So gateways typically don't know the devices. It's just decoupling LoRa to internet. So gateways have an internet connection, can be Ethernet backhaul, can be Wi-Fi, or even 4G. Network server implements the server side of the LoRaWAN specification. And what's good to mention here is that LoRaWAN devices, they don't have an internet connection. So it's not that there's any internet protocol in there. So all the things that you get for free in internet, such as IP addresses, transport control mechanisms like counting frames, recovering from frames, a routing of packets. That is all part of the LoRaWAN specification, and so you need a network server to implement the server part of that. And then on the right you have the applications, and they work typically with streaming data. And the network server publishes all the sensor data to the application. And that is where you can work in public clouds, or you can build applications. You can work directly with MQTT, for example. There are all kinds of options there. So, Jonathan, on the use case.
Okay, so LoRaWAN can be used for many different use cases and end customer applications and verticals. We're going to focus in this webinar particularly around cold chain monitoring. And as Alexander introduced at the start of this session, we're going to focus that into another subsegment of cold chain, into restaurants and food service areas, where it's really all about ensuring food safety. So if you look at that and you drill down, there is a need and a requirement to monitor and control food storage temperatures at all stages of that cold chain environment. Being able to automate that enables you to monitor and enables you to do logging of data, enables you to have compliance, and then additionally it enables alerting to the local operatives that there may be an issue in some of their cold chain areas. Traditionally, this was very much a human-driven environment where you were literally using pencils and paper and writing down temperatures, noting times, noting the area that was focused in, leading to the potential for human error and inaccuracies in the data. If you can automate that and do it digitally, you can reduce that human error and increase the accuracy. It becomes a simplified process. It doesn't need a team of people at different times to go and do this process. It can all be done automatically and in real time. If you do have an instance where, for example, there was a freezer door left open, nobody knew, and that was left open overnight, you can get food waste, a spoilage of that food that is no longer fit. You cannot serve that, and so there is an increased cost because you weren't monitoring that. Increased productivity and operational efficiency, I think it pretty much says what it is. You don't need as many people to be able to have the compliance and the requirements for cold chain monitoring as if you didn't have an automated wireless system. Fundamentally, you can protect your brand, your store, your chain, your business can be protected by the fact that you have this safeguarding system in the background, monitoring and controlling that temperature environment. And your data can be globalized as such. You can know how each of your individual stores, your restaurants are doing across a global perspective rather than a local only view with a paper and pen based system. All of this ultimately means enhanced food safety. So to summarize a single slide into what is 5 words, it's all about food safety and operational efficiency. Why LoRaWAN? So Johan introduced us to the concepts of LoRa and then LoRaWAN. But what makes LoRaWAN so good, particularly for cold chain monitoring? What makes it a technology that has been taken up by key systems integrators and vendors in this space to provide this wireless monitoring of temperature and humidity? So if you look at restaurants, you look at any food preparation areas, it isn't a simple box by box setup. It is very different. You can go from old historic buildings where you've got multiple different construction materials and techniques. They can be multi-floor. You can have very different layouts between one store to the next one, to one restaurant to another, all in different countries and different regions with different building and planning requirements. But what you can generally tell is that the kitchens themselves and the storage areas for that food are generally buried into the bowels or the back of the house. They are generally a long way from being a nice, clean, open environment from an RF perspective. You then look at the kitchens themselves. Anything to do with RF is something that will not like metal particularly. And so you think of a kitchen, you have packed that environment full of metal devices at different temperatures with different fluids inside some of them at different frozen environments. So you've got fridges, freezers, ovens, smokers, fryers, the list goes on. Again, from an RF, from a wireless perspective, you're talking about a pretty terrible environment for RF to be able to propagate cleanly. The sensors themselves, so in that freezer, where the sensor can be mounted, can be quite difficult. They are an environment that means those sensors are going to get bashed, they're going to get moved, they're going to have to be cleaned. They can't have things such as antennas hanging off them because that's another area where the product can go wrong. So just the physical environment inside of a restaurant or fast food service area can be difficult for the implementation of physically placing sensors themselves. The sensors can't be wired into the mains. There is a cost prohibitive structure to that means it wouldn't make sense. These must be battery powered devices. And also the batteries must be simple, universally sourced so that a food prep operative or the store manager can change the batteries in them without needing to be able to find very specific or unique batteries and to have a very complex installation process. It must be clean, simple, and easy to do. And then once fitted, they must last for a long time. You can't have, 5, 10, 20 sensors, whatever is needed for the environment, somebody going around changing them on a frequent basis. It must be a multi-year life cycle for those batteries in order to have a low-cost maintenance environment. And additionally, there is no one-size-fits-all of how many sensors does each business, each site, each restaurant, each food prep area is going to need. It could be 1, it could be 10, it could be 20, it could be, potentially 100, depending on the size of the environment. And again, you need a wireless technology and topology that can support that scalability of sensors and wireless signals in a small area. And finally, it must all be automated. You must be able to get the data from the sensor out and then ultimately onto the cloud and into the back-end systems and server software environments where that data can be manipulated, can be played with, and something useful can come out of that, a set of actions and insights that will enable better efficiency within that restaurant environment. And LoRaWAN provides it really does provide a significant benefit over a lot of other wireless technologies for this environment. It is very low power. It can be battery driven. It has a great low noise floor to enable great range. It can be used globally. And ultimately, it has a device, the gateway to cloud implementation structure that talks nicely into an environment where there are service providers doing this level of food compliance. LoRaWAN is ideal for cold chain monitoring in this restaurant fast food service environment. If you then look at it from a solutions perspective, what is it that Laird Connectivity can provide for these environments? So many years ago, we designed our first LoRaWAN solution, integrating LoRaWAN with Bluetooth Low Energy with BLE to be able to support what we looked at is short range networks in a wide area perspective. So we were using Bluetooth Low Energy to talk to remote Bluetooth sensors, and then LoRa for the long range bridge to a gateway for the longer range connection to an IP-based cloud network. And then what we found is the BLE inside of these devices could be used to have a local wireless display. You could use a smartphone or a tablet as a way to have a look at the data or to do configuration or control of the LoRa device itself. We then generated this package solution with integrated temperature and humidity sensor ICs, 2 AA batteries, the LoRa and the BLE radios, and put that into a secure rugged IP65 enclosure that can then be placed within any of these environments that this icon is showing. So whether that's in a walk-in freezer, whether that's in a prep area, whether it's in a fridge, and then those signals can be transferred to a gateway up to the cloud for processing, and then alerts and insights sent back to that business owner. So we're coming at this from the aspect of the hardware itself, from the devices, the sensors, and also the gateways that propagate that information to the cloud. So without going into huge depth, I'll quickly skim over a couple of the products that we have in this field. We have our big blue box, so to speak, our RG1XX Centrius gateway. This is an 8-channel LoRaWAN gateway that also supports 2.4 and 5 gig Wi-Fi, so 802.11 ABGN with a Linux core. And integrated into that is presets and configurations for TTN and TTI, so that data will simply flow in, be connected over LoRa, and then flow out over either a Wi-Fi or an Ethernet link up into a network server and then to the cloud. We also offer this in a IP67 variant if you're looking to place this outside of an in-building environment where you want an external product. That is then the gateway side to the sensor. So the sensors talk to that gateway, and this is the range that we have at the moment. It's our Centrius S1X series. Again, we've talked about the robust radios of LoRa. We don't need to go through that, but again, that enables that way to get out of the fridges and freezers in cold chain. 2 standard AA batteries, simple, easy, readily available, simple to change inside of a device. A secure, robust IP65 rated enclosure that can be wiped down and cleaned and stops the ingress of water and moisture and the general kind of materials that you get in a food preparation environment. It can support LoRa, and it can also support Bluetooth Low Energy. So there is supporting mobile applications where you can have configuration over LoRa or over that Bluetooth link. You can also do firmware upgrades over the same BLE mobile apps that are provided for both Android and for iOS. Inside of the device, there's a fail-safe mode for data logging in case, for example, power goes at the store or you lose your internet connectivity for whatever reason. The temperature and humidity sensors can still be logging data up to around 10,000 readings depending on the configuration. And then when the network connectivity comes back, enables you to pull that data from those devices and back into your compliance logs. In terms of global support, we have units available for Europe, for the North America, certified with FCC, IC, and CE certifications. And on top of that, we've recently provided for AU915 and AS923 regions with regulatory certification for Australia, New Zealand, and Taiwan, with many more to come. And finally, these are devices that can be fully customized, and we'll talk about that in the next slide. So the devices themselves, on the left, we have integrated temperature and humidity. Moving across one on the right, an external cabled temperature probe with a slightly extended temperature range if you need to get that probe out, or the sensor IC out of the bulk of the product itself. And then 2 products we're actively developing at the moment. The first is all the capabilities of the product on the left, so temperature and humidity, but then integrating a contact sensor, an open closed door sensor. So it'll now be able to support both temperature, humidity, and then open close. Again, if you consider this cold chain environment of a fridge or a walk-in freezer, you'll be able to monitor, for example, if the door has been left open too long and trigger alerts. You can monitor the temperature and the humidity all from a single device. And then finally on the right, we're working through some RTD external probes for higher temperature ranges, looking at different types of cooking procedures, whether they be smokers or pizza ovens or where a higher temperature is required. So an RTD external probe will be added as we go into next year. And then finally, customization. We talked a little bit about brand before. So we offer our standard products, our usual go-to-market products, whether they be the embedded Bluetooth, Wi-Fi radios that we've been doing for a decade or so. We also are a designer and manufacturer of our own antenna systems, from embedded antennas all the way up to 5G massive MIMO antennas for the next generation of 5G cellular networks. as well as these packaged products, the gateways and the sensors we've been talking about here. We can then, because we are the designer from a software, hardware standpoint and manufacturing, we can do customization of those standard products. So change the logos on them, change the labels, change the branding, change the enclosures, add some custom configuration programming to meet the needs of a specific use case for a customer. We can write specific new firmware or mobile apps to support whatever the customer requires. And we can also do secure signed firmware images if that's needed. And that all the way there on the right can be taken to whatever level the customer would like to achieve. As well as making standard products, we can produce and deliver any form of custom development. So we can do just mobile application development. We can do mechanicals, enclosure design. We can do cloud integration support, custom antenna design, all the way from a complete out-of-box IoT product development, again, all the way through the design cycle to mass production. So kind of 3 tiers of products and capabilities we can offer our customer base. If I now hand over to Johan to talk away from the hardware piece that I've been diving into the required kind of LoRaWAN network server to bring this whole solution together for cold chain.
Right. So as I said, the gateway talks to the network server. So that's how the things align here. So what is a network server? This is the architecture slide of V3 version 3 of our stack. It's called the Things stack. We have an enterprise version, also the Things enterprise stack, and we have different components here. We have on the gateway facing side, we have a gateway server. So that's a component that really maintains the connections with the gateway, but also monitors if the gateways are connected or if they go offline. We also gather statistics here about how many packets the gateway receives, and also about signal quality and channels, and also channel performance. The network server is really the implementation of the LoRaWAN specification. So that's really about decoding packets that devices send, identifying devices, processing commands that we send back and forth about which channels to use. So a lot of stuff that we abstract away from the application is in the network server. The application server is already lives in the application domain. So the application server decrypts the payload that the sensors send. Payload processing also happens in the application server. The joint server contains the root key. So they are separate from the network and from the application server. And the root keys are used to activate devices on networks. The identity server contains the registry of gateways, users, applications, so which organization has rights to which applications and gateways. So it's user login. We support for our enterprise customers also a single sign-on with their OpenID systems. Corporate authentication is supported. And then on the right, we have the integration. So that is for application developers to work with their data. So like I introduced, we support MQTT and HTTP for low-level access, but we also have integrations with the popular cloud platforms. So that's the a little bit of the overview of the slide. It's actually pretty easy to develop additional integrations. You can build applications with a specific with the payload formats that we use, and then because our stack is really portable, you can deploy it in the cloud, you can deploy it on premises, on site, but all the APIs and message formats are the same. That makes it really easy to work with different types of LoRaWAN network deployments. The gateway server, like I said, it maintains the connections with the gateways. What's also good to mention here is that we support serving frequency plans here. You can, depending on the the region where you are, we can provide configuration files for the gateways so that they use the channels that you want the gateways to use. So our enterprise stack, this is our new product, V3. So we support the published LoRaWAN versions. So there's a 1.0 range of versions and a 1.1. The LoRaWAN device classes A and C. Class A is typically most of the devices are Class A devices. They behave as Class A devices. Class A means that the device sends telemetry to the network, basically, like many sensors do. Class C is when devices are continuously listening. So that can be used for remote control, so turning on and off lights or valves, things like that. There's also E on our roadmap, and that is kind of an in-between version. The Things Enterprise Stack also supports backend interfaces, and that means that it's interoperable with other networks. So we have a joint server, for example, which you can operate yourself, or you can use our hosted solution. But that joint server can also be used by other networks. And likewise, we support also external joint servers. So if you work with devices on other that are provisioned on other joint servers, then that works as well. And that really comes down to what really the power is of LoRaWAN, is that you can have all kinds of deployments. And also you don't have to deploy all these components that I just presented on one particular server. So the Things Enterprise Stack is kind of it's a bunch of components, but you can choose depending on the use case what you deploy where. And so, for example, you can have a joint server where you have your keys provisioned, but you can have, for example, on-site deployments of the network server and the application server. And that means that all traffic remains local because that only goes to the network server and application server, but only the joint procedure would go through a joint server. So that level of control is something that we provide with our enterprise stack. We also have a low-level insight in everything that happens. So we publish a lot of events also on the LoRaWAN level. We have a lot of advanced capabilities for managing users and their rights, also grouping them in organizations. You also have a lot of control over the devices, regional settings, but also media access control settings, such as the channels that they use, the data rates that they use, and you have a lot of feedback also in what works and what doesn't work for customized frequency plans. Yeah, the SAML as a single sign-on is what I just mentioned, when you can integrate your own corporate login system and integrate that in the enterprise stack. We have different deployment models. So again, I think this is really one of the most powerful things about LoRaWAN, is that you can deploy it in so many different ways. So we have cloud-hosted, dedicated cloud-hosted, self-hosted, and marketplace launcher. Cloud-hosted is where we operate the network server on our infrastructure, and you can connect your gateways to it. You have your own environment of gateways and applications and users. It's multi-region. We manage scaling, we manage the infrastructure. We also provide the service level agreement and support. Dedicated cloud hosted is for more advanced and large deployments, which need multi-tenancy. And that can be used, for example, by large resellers. So let's say you are a system integrator that provides cold chain solutions to many large accounts. Then you may want to choose dedicated cloud hosted and offer your solution in multiple separate tenants to your customers. Dedicated cloud hosted also runs on dedicated infrastructure, and it's also SLA backed and supported by the Things Industries. Self-hosted is where you operate everything yourself, and that means that you get our binaries and Docker images and instructions to deploy the stack in your own infrastructure. That means that you are responsible also for scaling and for the service level. Obviously, we don't do any operations, then we don't even need access to the infrastructure. So this is for really advanced corporate deployments. And finally, we have a marketplace launcher, and those are launchers that are available in the Azure, AWS, and Google Cloud marketplace. And yeah, I'm happy to announce that we are launching our AWS marketplace launcher these days, and that allows you to, with just a few clicks, to launch the entire stack in your own AWS account, and deploy your private network easily. Also good to mention here is that it's really easy to migrate between these deployment models because all the APIs are the same. The model of the devices, how everything is stored and managed is all the same. And that means that you can start on cloud hosted and upgrade later to dedicated cloud hosted when your deployment gets bigger and when you want a dedicated infrastructure, for example. But you can also start with the marketplace launcher in your own AWS account and migrate later to cloud hosted or the other way around. So that's we are very flexible there. So Jonathan, take it from here.
Okay, there's only a couple more slides before we get into kind of the Q&A session of this. So why Laird Connectivity in the Things Industries as a partnership for cold chain monitoring and LoRaWAN? I put this together because as far as I have seen through years of developing wireless hardware and then enablement of that hardware through multi-wireless solutions to get it to the cloud, there is no one-size-fits-all solution from a hardware, middleware, software, cloud perspective. Successful IoT, as we have seen it, all happens in partnership. A partnership between the hardware vendors, the server vendors, all the way through to the customer at the end of that. And really, it's about bringing together the best of both worlds. So Laird has come from a wireless background. Many decades developing wireless connectivity and multi-wireless connectivity, certifying at the antenna development and supporting that to a global customer base. LoRaWAN, no problem for us, and from a hardware and a development certification standpoint, the firmware, all part of what we as a business have as core competence. But then building that up into a scalable global network with a LoRaWAN network server, the joint servers that Johan has talked through, and all of the elements required for a full deployment and then linkage into the cloud. That needs skills and capabilities that our partner TTI brings to the table. All of this, the connectivity, the hardware, the firmware, it all enables our customers to generate insights and really spend their time focusing on what matters to them. Their brand, their restaurant, their chain, the data that's coming from these sensors and devices in a secure, scalable manner. Lead Laird Connectivity and TTI to be able to bridge that data to the cloud and enable you as the customer to be able to ensure that you have compliance and control over the environments that these sensors and gateways are operating in. More specifically, Johan, I'll throw the next one at you. Just to look at a few additional benefits that this tie-up between Laird Connectivity and TTI has.
Yeah, so deploying LoRaWAN network is really many, from deploying like a Wi-Fi solution, for example. Laird and TTI are really easy to deploy without addition of gateways, because these can be pre-configured to our network server, and the same goes for support, where we sync regularly. Those are really key benefits for the customer to deploy networks fast without too much hassle. So yeah, I think that's it for now. And then Alexander,
yeah,
I'm curious
great
to hear if we have any questions.
Yeah, thanks. So to the audience, apologies for Johan's voice breaking up. I think that's due to internet connection. Anyway, so I'm also aware of your time, but I wanted to discuss a couple of questions which I thought were interesting. So this one is for Jonathan, I guess. So could you say something about the, let's say, average return on investment that these kind of cold chain applications are achieving in general, if you can say something about that?
I per se don't have any kind of hard and fast figures that I could provide here, because simply put, from our standpoint, from a layered connectivity standpoint, we're providing the hardware, the sensors and the gateways, which are the enablers of the data to get through to the TTI network server, and then through that, and then ultimately up to an application server. So the application server being our end customers, so the systems integrators or solutions providers that are providing food compliance then to the end customers. So, whoever that may be is then servicing those end restaurants, and it's those customers that are getting the return on investment. So from our position, we're kind of 2 steps removed from that return on investment calculation, and it'd be something that, it would be ultimately our customers having to provide that. And so that's a long-winded answer to say, no, I can't give you a figure as of now.
Okay, so maybe a little bit more on the technology side rather than the business case side. Someone is asking about the coverage inside buildings, inside restaurants. What is a typical deployment look like? What is the number of preferred gateways inside a restaurant, for example?
Okay, so we have implementations globally, and in reality, in the kind of the food service industry, in the fast food restaurants that we found some success, we're generally looking at a setup that is a single gateway to, at best, the biggest number we've seen is 12 sensors in an individual restaurant location. The average number of sensors being roughly around 6. So most implementations we've seen, 1 gateway, 6 sensors is about the average to cover that environment. But again, one of the nice things with LoRaWAN is that if you do need more range, you do need to cover additional areas, you can literally just drop in another gateway to service that area and increase your scope.
All right. Question for Johan. Can you say something about the airtime limitation on a private network?
So there is only a limitation of regulations on private networks. And in Europe, for example, we have a duty cycle limitation, which is, I think, between 0.11 and 10% based on the subband. And that means that you cannot really stream data, but for telemetry, you have enough airtime available. So typically, duty cycle is not really a limiting factor when deploying LoRaWAN solutions, especially not censoring.
All right, great. So there are some more questions coming in. Some are pretty specific. What I suggest is we make an end to this webinar. We will be able to answer questions if you get in touch with us. You can request a demo. Have a look at the links that are now in the screen. Also, we're going to share these slides with you, and we'll also put a replay of the webinar onto our YouTube channel. We'll inform you about that. So for now, thanks very much, Johan and Jonathan, for being our presenters, and I hope that the audience has gained some knowledge and some better understanding how to deploy this technology by ourselves.
Thank you.
Thank you. Thank you, Alexander.
Thank you very much. Thank you.
Thank you. Bye.
Have a good day, everyone. Bye-bye.